लास्ट टू लेक्चर्स किसी का लगता माइक्रोफोन ऑन है. So in last two lectures we discussed Wilson's theorem and also Euler's phi function. So we start with the Euler phi functions. This is nothing but the collection of those positive integers less than n and co-prime to n. So this is a way to find Euler phi function of any positive integer, and if n equal to 1 we fix n phi of n equal to 1. And then we already discussed several examples based on the Euler phi functions and some way to how to compute the Euler phi function. Like if your n is a prime number p, so there is a easy way to compute Euler phi function using this result quoted as theorem 7.0.9. If n is a prime number, then you can use this method that tell that phi of that prime n is nothing but n minus 1, and this is nothing but the result which is quoted as theorem 7.0.9. And suppose that number is not a prime but power of some prime like p power r. If n is equal to p power r, then using this result quoted as theorem 7.0.10, we can compute the Euler phi function of that n, and this is nothing but suppose n equal to p power r, then phi of n is same as p power r minus p r or r minus 1. This is nothing but just you take the common p r minus 1, so you get the p minus 1 factor into p power r minus 1. And suppose your nature the number n is not of the form p or p power r, like this is, that have a general form. So we for that we need a another concept known as a multiplicative function, and there is a one result that say that your Euler phi function is a multiplicative function. That means if GCD of any two positive integer m and n is 1, then phi of m into n is equal to phi of m into phi of n. And using this result, theorem quoted as theorem 7.0.12, we observe the general result quoted as theorem 7.0.13, and that say that if n is a product of several primes like n equal to p1 power r1, p2 power r2, and so on pk power rk, then using this method, you can compute your Euler phi function of that n. And then Mobius phi function is not so interesting Mobius for this course. This concept is also very important, Mobius phi function and mu function. But here we are concentrating on Euler phi function only here in this course. Now we have computed Euler phi function for several positive integers. So I think you should also read and see the proof or solution of these problems. And here also I compute here Euler phi function of 10 factorial. So see here again I did the prime factorization of 10 factorial, but 10 factorial is a big data. So the last question someone of asked that what is the number of 0 in the last in the 10 1000 factorial. I think we will not get by using this one. So then I included these two results in the today morning, and this is an interesting result. I quoted as proposition 7.1.14, and I'm going to discuss this result quoted as 7.1.14. See, suppose we have any positive integer which is like n equal to 1. So you know that phi of n equal to 1. If n equal to 2, then you know that phi of 2 is equal to Phi of 2 is nothing but 1. And if n equal to 3, then phi of 3 is equal to nothing but 2. Phi of 3 is equal to 2. Phi of 3 is equal to good. So, and if n equal to 4, then phi of 4 is equal to 2. If n equal to 5, then phi of 5 is equal to 4, and so on. So you can see that for any positive integer n greater or equal than 3, I'm just by that should be n greater or equal than 3, phi of n must be an even number. You can also observe just by taking any positive number greater or equal than 3, you can see that phi of that number is a even number. Like 10, n equal to 10, the phi of 10 is equal to 4. If your n equal to 100, then phi of 100 is, phi of 100 is, what is phi of 100? Anyone? What is the phi of 100? Can you compute? कितना वैल्यू होगा यार? Euler phi function of 100? Anyone?
So 40.
40. And what is the Euler phi function of 1000? Anyone?
$400.
So how you get 400? Tell the method, your method.
So 1000 equal to 2 to the power 3 into 5 to the power 3.
5 or 3, good.
And phi of 2 to the power 3 is 4.
Forward.
And phi of 5 to the power 3 is 100.
100, yes, good. Oh, thank you.
So
That is your
then
400.
4 into 100, sir.
Yeah, so that means whatever number greater or equal than 3, you can see that phi of that number is always an even number, always an even number. And you are going to verify mathematically of this statement that say that Euler phi function of any positive integer which is greater or equal than 3, if I'm mistaken, I just write greater or equal than 3 because n is equal to 3, then you know that phi of n equal to 2, which is also even number. So I have to include in also here in this statement, and you are going to verify mathematically that phi of n, where n is greater or equal than 3, is always an even number. So we'll do this mathematical verification case wise. In first case, I assume that because n is a positive integer, the n can be a odd prime. N can have a odd prime factor because n is a positive integer like 10. Think about 10. So 10 has a odd prime factor 5 because 5 is a factor of 10 and is odd. That means 10 is a positive integer which is a prime factor. Think about 12. So 12 can be written as 2 into 2 into 3. That means 12 is also has a odd prime factor, and that prime factor is odd prime factor is number 3. Think about 8. So 8 is about 2 into 2 into 2. That means 8 doesn't have a odd prime factor. So see, suppose we have an integer, there is only two cases. That integer can have a odd prime factor or cannot have a odd prime factor. There's only two cases. So case wise we are going to discuss. In first case, I assume that n has an odd prime factor. Can have many odd prime factor, but at least one prime factor. So that prime factor I call P. That means factor means उस number से उसको divide कर सकते हो. So P is odd prime factor. I call that prime factor is a P. Then your n can be written as p power k into m. Suppose that you are thinking about 100, n equal to 100, then you know that 100 has a prime factor, odd prime factor, and that odd prime factor is equal to 5, because 100 can be written as 2 into 2 into 5 into 5. That means 5 is a factor which is an odd prime. That means that 100 has an odd prime factor, which is nothing but 5 in this case. And now we can write your 100 as a 5 square into 4. 5 square into 4. That's why I write your n here. Whatever n doesn't matter. Only is that n has an odd prime factor. Then I collect all those power of that prime factor p, and I can write n is equal to p power k into m. Because we are collecting all the factors of p in n and make a group p power k, that means GCD of p into m equal to 1. So that means m don't have any prime factor p. Then because p is a odd prime factor, that means p minus 1 is an even number. Like p is equal to 5, then p minus 1 is equal to 4. If p is equal to 7, then p minus 1 is equal to 6, and that is even number. That means p minus 1, if p is a odd prime, then p minus 1 is an even number. Now we consider phi of n, because n can be written as p power k into m, and p GCD of p and m equal to 1. That means GCD of p power k in and m is also 1. That means you can write phi of pk into m as a phi of pk into phi of m. And we have a formula that give the values of phi of pk, p power k. This is nothing but p power k into p power k minus 1 into phi of m, because you don't know what about the character of m. That's why I put phi of m in the same way. Now p power k minus p or k minus 1 can be written as p minus 1 into p power k minus 1 into phi of m. Now that means phi of n can be written as the product of these three components. First component is p minus 1, other component is p power k minus 1, and third component is phi of m. And you know that p minus 1 is a even number. That means phi of n has a factor which is even number. That means the phi n is an even number when your n has an odd prime factor. So in that case, we got the proof, mathematical verification. Now in another case, when your n has no odd prime factor, can you tell a number which has no odd prime factor? At least 2 or 3 positive integer, at least 2 and 3, please.
8, sir.
Sir,
8. Next.
16.
Next.
sir, any number written as 2 to the power n?
Any number that can be written as 2 power n. That's why I have it right here. So suppose that n has no odd prime factor, that means that n can be written as 2 power k for some k belong to a set of positive integer. And then if you compute phi of n, then phi of, because n can be written 2 power k, then you get a phi of n is same as phi of 2 power k, and this is nothing but phi of 2 power k. If you compute that, this is nothing but phi of 2 power k minus 1. So which is, see that 2 is an even number. The 2 power k minus 1 is also even number, because 0 is also even number, but 0 is not going to, you will get. So see that means an even number. Suppose k is equal to 1, k minus 1 and something. So here you see that only thing is because k cannot be 1, because n is always greater or equal than 3. So k is greater or equal to 2 only. So that is always get the even number. Good. K cannot be 1 because your n is a of positive integer which is greater or equal than 3. So n k cannot be 1 equal to 1. That means 2 or k minus 1 is an even number. So that is your verification, and this statement say that whatever n doesn't matter, that if that n is greater or equal than 3, you always get phi of n as an even number. So this result I included. This is interesting result, and always remember that phi of n is an even number when n is greater or equal than 3. Now, based on the concept discussed on the Eigen function, I compiled few objective question one by one, and also I add some question answer. Like, see, suppose that this is your first question, and I copy from somewhere from Google, and this question is asked in the ISI B math entrance. What is the question? Suppose we have P as an odd prime. Then this question asks that the number of positive integers less than 2p and relative prime to 2p is. Can you tell the answer? कितने पॉजिटिव इंटीजर्स है जो 2p से छोटे हैं और 2p से के को प्राइम है? वो p is an odd prime. Can you guess your answer?
Sir, p minus 2.
P minus 2. How we get P minus 2?
सर अगर p से रिलेटिव प्राइम करे तो p minus 1 होता है, तो 2p से 2 मल्टीप्लाई कर, सॉरी सर 2p minus 2.
How we get 2p minus 2?
सर p का p minus 1 होता है, तो 2 मल्टीप्लाई कर देने से.
See this question. Please again read this question that say that your p is an odd prime. That means p is different from 2. Your 2 is also prime, but your p is nothing but a odd prime. Is p is can be 3, can be 5, cannot be 2. So your p is an odd prime, and the question is asking for that you give those number of positive integer which are less than 2p, and those positive integer must be co-prime to 2p.
p minus 1 सर.
How you get to p minus 1?
सर यदि p is equal to 5 लेते हैं तो 2p 10 होगा, और 10 से 1 3 और 1 3 7 और 9 रिलेटिव प्राइम होगा. दैट मीन ये चार नंबर हो गए. उसी तरीके से अगर p is equal to 3 लेते हैं तो 2p is equal to 6 और 6 रिलेटिव प्राइम 1 and 5 है. मतलब 3 लेते हैं तो 2 आता है, 5 लेते हैं तो 4 आता है. इसी तरीके से p जितना लेंगे तो उससे एक कम आता है.
बट p तो b की तो संख्या बहुत सारा होगा ना, बिकॉज ऑड प्राइम आप जानते हो नंबर ऑफ प्राइम्स इनफाइनाइट, और एक ही इवन प्राइम होता है 2. उसके अलावा जितने प्राइम होते हैं सभी ऑड प्राइम होते हैं. जस्ट ऑब्जर्विंग थ्रू ओनली 2 एग्जांपल्स, तो उससे कंक्लूजन कैसे कर सकते हैं? तीन या 5 एग्जांपल दिखा के कि सर इसमें हो रहा है, इसलिए हम कह सकते हैं
सर यहाँ पे अगर फाई ऑफ टू पी ले ले तो जीसीडी ऑफ टू और पी इक्वल टू वन, देन फाई ऑफ टू पी इक्वल टू फाई ऑफ टू इंटू फाई ऑफ पी,
गुड।
और फाई ऑफ टू इक्वल टू वन और फाई ऑफ पी इक्वल टू पी माइनस वन, देन when you multiply this one into p minus one, then answer will be p minus one.
Yeah, good. Your answer is correct. Thank you. So see that that's why I choose p is equal to a prime number, and when p is odd prime, then you know that GCD of 2 and p is a 1. And you see the question is clearly say that you have to count, you could use the Euler function here, because that function compute the number of positive integers which are less than n and co-prime to n, and here n is 2p and n is equal to 2p, because 2 and p are co-prime number, then your Euler function is multiplicative in nature. That means if you apply phi of 2p, then you will get phi of 2 into phi of p, and phi of 2 you know that 1, and phi of p is equal to p minus 1. So 1 into p minus 1 will get the p minus 1. That means your answer will be p minus 1. Your answer is correct. Thank you, whoever. And this question is asking in terms of ISI Kolkata B Math entrance in 2006. I copy from Google this question in today morning. Now, so write something mathematical verification. Now, come to the another question, and I asked in question number 2. It says that suppose we are any odd positive integer, then if you compute phi of 2n, then phi of 2n is equal to which values among these four?
Phi of n.
Phi of n, how you get phi of n?
So phi of 2 into phi of n. Then phi of 2 each 1.
So how you can write phi of 2 n is equal to phi of 2 into phi of n? How can you write?
सर यहाँ पे दिया है कि n odd positive integer है तो
Odd
phi of
positive,
2n.
good. Yes. So when n is odd positive integer, that means GCD of 2 and n is equal to 1. That's why you can use your multiplicative nature of your phi. Then you can write phi of 2 into phi of n, and phi of 2 is equal to 1, and phi of n, because n you don't know of which nature, then you just put phi of n, because n तो फॉर्म ही नहीं जानते n है क्या. So we'll get a phi of n. Now in the next question I give, if n is an even positive integer, then I ask for the value of phi of 2n among these four options. Can you guess?
Sir, 2 into phi n.
2 into phi n. How you get 2 into phi n? Please.
सर मल्टीप्लिकेटिव प्रॉपर्टी से phi 3 2 आएगा.
मल्टीप्लिकेटिव प्रॉपर्टी यहाँ पे यूज कैसे होगा?
सर जीसीडी सर 3 और n का 1 ना होगा सर.
3 कहाँ है? ये 2 phi of 2 n है. आई एम आस्किंग फॉर क्वेश्चन नंबर 3.
ओ सॉरी सर 4 देख रहे थे.
सर phi of n होगा.
Phi of n. How you get phi of n?
सर n even positive integer है.
हाँ.
तो सर सॉरी सर मैंने गलत ले लिया सर.
ट्राई करो प्लीज.
सर 2 into 5 ऑफ एन हो जाएगा।
How please? Can you explain your answer?
सर ये सर 5 of 2 टू द पावर के का फॉर्म में सर हो जाएगा ये।
कैसे कैसे प्लीज?
सर हम लोग एक एग्जांपल भी ले सकते हैं ना, एन की जगह पे 4 नंबर रखते थे।
एक एग्जांपल से आप कैसे कर सकते हो?
मतलब कुछ चीजें रिमूव हो जाएंगी।
जनरलाइज हो जा रहा है सर।
हाँ, ये चीज कैसे कर सकते हो? दिक्कत तो ये है, हम वोट देने जाते हैं, देखिए पॉइंट देख लेते हैं, फलाना ये काम किया है, मेरे गांव का गली बनाया है, इसलिए वोट दे रहे हैं, और बहुत सारी दिक्कतें हैं। जस्ट ऑब्जर्विंग वन पॉइंट गुड, अच्छा है, हमारे कास्ट को बहुत सपोर्ट करता है इसलिए वोट दे रहे हैं, हमारे रिलीजन को सपोर्ट कर रहा है इसलिए वोट देंगे, हमारे भैया के शादी में आया था इसलिए वोट देंगे। एक पॉइंट से कैसे आप एनालिसिस कर लो कि वो बंदा सही है और ये रिजल्ट सही हो सकता है? Okay, I'll tell the trick. Suppose because n is a even positive integer, means n has a factor, 2 is a factor of n, है ना? यदि n आपको पॉजिटिव इंटीजर है, इवन पॉजिटिव इंटीजर है, इसका मतलब है कि उसके अंदर 2 एज ए फैक्टर कहीं बैठा हुआ है। तो जितने 2 के उसके पार्ट है सब एक दफे निकाल लो, बाहर कर लो 2 वाले फैक्टर, और उसको उसके बाद निकालने के बाद यू कैन राइट n इक्वल टू 2 पावर सम k इंटू m। उसके बाद यूज करो तो फिर बनेगा 2n इज नथिंग बट 2 पावर k प्लस 1 इंटू m, और m में तो 2 का कोई पार्ट बैठा नहीं है, वो सभी 2 वाले बाहर निकाल लिए हो, तो जो बचे वो ऑड फॉर्म का कुछ होगा, उसमें 5 लगा के देखो तो क्या निकल रहा है। गेटिंग माय पॉइंट? because n is an even positive integer, then that means 2 is a factor of n. Then you collect all the factor which is a multiple of 2, yeah, which is can be written as 2 power k, and then finally you can write n as a nothing but 2 power k into m. That means 2n is nothing but 2 power k plus 1 into m. Then you apply your phi, because GCD of, in that case, GCD of 2 power k plus 1 into m is equal to 1. Then you can use your property of multiplicative function, and you can write phi of 2 power k plus 1 into phi of m. उसके बाद प्रोसीड करो, क्या है? चलो टाइम ले रहे हो, फिर इसको ट्राई करना और कोशिश करना, इसे आंसर मिलते ही कॉमन व्हाट्सएप पे आपको मैसेज करना सॉल्यूशन के साथ, ताकि सॉल्यूशन क्रॉस वेरीफाई कर लें हम. Come to the question number 4. And can you tell me the answer of this question? Suppose you have n as a positive integer which is divisible by which is not divisible by 3. Then what is the value of phi of 3n among these 4 options?
Two into five of n.
Which one?
2 into 5 of n.
2 into phi of n. How we get 2 into 5 of n?
So 3 dot divide n, then GCD of 3 and n equal 1.
GCD of 3 is not dividing n, means n don't have any factor of 3. So GCD of 3 and n equal to 1. Good, yes. Then
Then phi of 3 into phi of n. Phi of 3 equal to 2.
yes, good. Okay, that means your
Phi-
answer is yes. Your answer is A. A is correct. Thank you. Your answer is correct. Correct answer is A. Good. Now come to the last question. Suppose n is a positive integer which divisible by 3. In this case, what is the phi of 3n?
So ये वही 3 वाला क्वेश्चन है सर.
3 वाला क्वेश्चन, सेम क्वेश्चन है, सेम क्वेश्चन. प्लीज इसका भी ट्राई करना, इसका भी आप लोग ट्राई करिएगा. इसका भी सॉल्यूशन मिलते ही विद सॉल्यूशन, नॉट ओनली डायरेक्ट आंसर, सॉल्यूशन के साथ आप लोग कॉमन व्हाट्सएप पे मैसेज करिएगा, हम क्रॉस वेरीफाई करेंगे, देखेंगे. और एक और रिक्वेस्ट है, पर्सनल रिक्वेस्ट है कि आप लोग गूगल से जहां से भी ऑब्जेक्टिव क्वेश्चन आपसे मिले तो आप मुझे पर्सनल व्हाट्सएप करिएगा. मैं कलेक्शन कर रहा हूं जो आपके लिए हो सकता है और आपके आने वाले जूनियर्स को भी हेल्पफुल हो सकता है. तो यदि कोई जो भी इंटरेस्टेड है नंबर 3 में, जो भी ऑब्जेक्टिव क्वेश्चन आपको गूगल से या कहीं बुक से मिलता हो, उसको फोटो खींच के या लिख के मुझे कॉमन व्हाट्सएप करिए, पर्सनल व्हाट्सएप जो नंबर है उसको व्हाट्सएप करिएगा. मेरा नंबर पता नहीं कुछ लोगों को होगा, हम अभी व्हाट्सएप कर देंगे 8404934146. सुदर्शन, आई थिंक यू नो माय व्हाट्सएप नंबर. सुदर्शन, आर देयर?
यस
हाँ, तो मेरा पर्सनल व्हाट्सएप नंबर शेयर कर देना. और जो भी नंबर 3 में इंटरेस्टेड है और कोई भी क्वेश्चन मिले उसको नंबर 3 का ऑब्जेक्टिव टाइप का, तो ज़्यादा सही रहेगा कि लर्निंग अच्छा ठीक ठाक होता है ऑब्जेक्टिव से पहले, फिर सब्जेक्टिव तो है ही. तो जितने भी ऑब्जेक्टिव क्वेश्चन आपको मिले मुझे पर्सनल व्हाट्सएप पे मैसेज करना, जो भी है नंबर 3 में जिसको क्वेश्चन मिले. तो नाउ आफ्टर दैट वी हैव सम एक्सरसाइज, प्लीज ट्राई. ये क्वेश्चन 3 मैंने सॉल्व किया है, ये डिस्कस किया है. ये क्वेश्चन हमने यहीं से स्टार्ट किया है, तो ये तो ऑलरेडी डिस्कस क्वेश्चन है. और यू कैन इजीली कंप्यूट द phi of 2010 and phi of 10,000. Please try. And after that, we discuss the Wilson theorem in the next lecture, previous lecture, and that Wilson theorem say that if your prime number p, then that prime number p always divide this number. What is the number? P minus 1 factorial plus 1. In congruent form, you can write p minus 1 factorial congruent to minus 1 modulo p. And also we discussed proof of this statement quoted as theorem 8.0.1. So we already discussed proof of this one. And also we have several examples based on the Wilson theorem. Now, I included this result in the morning, today morning, and this result say that the Wilson theorem say that if you have prime number, then that prime number p divides p minus 1 factorial plus 1. Now, conversely, if you will see that, suppose we have any positive integer which is greater than 1, and that n divides n minus 1 factorial plus 1, then that n must be a prime number. Think about in converse way of Wilson theorem. This is a converse of Wilson theorem. We can say that they say that suppose we have a integer which is greater than 1 and that integer n divides n minus 1 factorial plus 1, then that integer n is nothing but a prime number, and that is a converse of Wilson theorem, and proof is not so lengthy. You are going to explain this proof. So now by contradiction we assume that n is not a prime number, that means n must be a composite number. So I call that n is a composite number. That means n can be written as, because number is composite, so n has a factor, so I write n as a into b for some a and b which lie between 1 and n. So what I did, because I start with contradiction and assume that n is not a prime number, that means n is a composite number, then you can write your n as a into b, where a and b is ranging from 1 to n. Now, because the number a is less or equal than n minus 1, that means a must divide n minus 1 factorial. क्योंकि a उसके अंदर बैठा होगा, बिकॉज n minus 1 फैक्टोरियल का कैरेक्टर स्ट्रक्चर देखोगे तो उसमें a एज ए कंपोनेंट बैठा रहेगा. That means a divides n minus 1 factorial, and this information is already given that your n satisfying this equation. That means n divides n minus 1 factorial plus 1. That means in congruent form, n minus 1 factorial is congruent to minus 1 modulo n. So see, now think about your n can be written as a into b. That means a divides n and also b divides n, but we are not using your b character, or we are only using a character. So a divides n and n divides this quantity. So by transitive relation we can say that a must divide n minus 1 factorial plus 1. So see, a only divide n minus 1 factorial, and also we are getting that a also divides n minus 1 factorial plus 1. So then a must divide difference of n minus 1 factorial and n minus 1 factorial plus 1. So I write here, that means a must divide the difference of n minus 1 factorial plus 1 and n minus 1 factorial, because individually a divides both of them. So I write here a divides their differences, and that means a divides 1. That is a contradiction. That is a contradiction because a is, you are taking a is greater than 1, less than n, and a divided is 1. That is a contradiction. That means your n must be a prime number. Must be a prime number. So this is a converse way to think any positive integer greater than 1 satisfying this condition that n minus 1 factorial is congruent to minus 1 modulo n, then that n must be a prime number, must be a prime number. And also I include this Euler theorem, and I did not write its proof. Proof is lengthy. So what is this theorem? Euler's theorem. Suppose we have a two positive integer a and n with one condition, that the GCD of a n equal to 1. Then this result say that a power phi of n is congruent to 1 modulo n. That means n divides a power phi n minus 1. And this result is interesting for this type of questions. Like, see that someone asked that what is the units digit of this big number? Can anyone tell what can be the units digit of this number? 3 power 100.
सर 1 होगा.
How we get 1?
So 3 to the power 4 81, then unit digit 1, then 3 to the power 4 whole to the power 25.
Again, please. Again, please.
So 3 to the power 4 81,
Yeah.
the unit digit 1, then
Yeah.
3 to the power 4 whole to the power 25 होगा तो 1 होगा.
उसका unit digit 1 ही होगा. Yeah. So same thing you are going to use by give the answer using Euler's theorem. And this is same thing. This is what I write here. This result is same as equivalent to obtaining the smallest non-negative integer to which 3 power 100 is incongruent to modulo 10. क्वेश्चन ये है कि आपको 3 पावर 100 मॉडुलो 10 निकालना है. Now see, I'm going to use the Euler's theorem, and that say that a power phi of n is congruent to 1 modulo n. So in this question, I call a is equal to 3 and n equal to 10. Then GCD of a and 10 is a and n equal to 1 because a equal to 3 and n equal to 10. GCD of 3 and n equal to 1. Then you can use your Euler's theorem, and I also compute the phi of 10 is equal to 4. You also see that phi of 10 is equal to 4. Then I use the Euler's theorem, and that will give that 3 power phi of n means 3 power 4 is congruent to 1 modulo 10. Then, because we are looking for the unit digit of this big data 3 power 100, so we consider 3 power 100, and 100 can be written as 4 into 25, so I write this way, and you can manage it this way. And because 3 power 4 is congruent till system is nothing but 1, so I write 3 power 4 is equal to 1, which is power 1 power 25 modulo 10, and 1 power 25 is the same. That means when you divide this big number 3 power 100 by 10, will get the remainder 1, and that is your unit digit. Your last पे बैठा हुआ है, so that is your 1. 1 is a unit digit of this big data 3 power 100. Similarly, if I ask that what is the last 2 digits in the decimal representation of this integer 3 power 244, and also I write solution of this question. Please read out. I don't think we'll get the difficulties. This question is same, and then something I write. I'll discuss already there. This problem we have already discussed in the previous lecture. So now I think we have covered all the number 3 concepts given your syllabus. कुछ छूट रहा है क्या? नंबर 3 कुछ सिलेबस छूट रहा है क्या? कोई बताएगा? नंबर 3 कोई किसी को सिलेबस है अभी? डिस्क्रीट मैथमेटिक्स से किसी पास सिलेबस है?
हाँ सर है।
हाँ, तो उसमें देखो, उसमें जो
सर
नंबर
लास्ट में मोबियस फंक्शन एंड मोबियस इन्वर्सन फॉर्मूला है लास्ट में।
मोबियस इन्वर्जन फार्मूला छोड़ देते हैं, वो बहुत बड़ा थ्योरम है और 2-3 पेज का है, उसको छोड़ देते हैं। उसके पीछे बहुत सारा लेमा भी है, उसको छोड़ देते हैं। मोबियस फंक्शन डिस्कस हो गया है, और उसके अलावा बताओ।
इसके बाद और नहीं है, ये लास्ट है सर।
मोबियस इन्वर्सन फार्मूला छोड़ दो क्योंकि उसका प्रूफ है बहुत लेंथी है।
सर नंबर थ्योरी में और कुछ नहीं है।
और कुछ नहीं है ना?
लास्ट ऑयलर्स फर्स्ट 5 फंक्शन तक ही है।
5 फंक्शन, ठीक है। तो आप लोग डिस्कस कर लेंगे, कोई डाउट होगा तो आप लोग बताइए, पूछिएगा। नेक्स्ट हमें लगता है कि हम लोग फर्स्ट यूनिट ऑलमोस्ट डिस्कस कर लें, कुछ बचा हुआ है फर्स्ट यूनिट में। और वो शुरू करेंगे, कमेंटरी शुरू करेंगे, ठीक है। कल परसों से कमेंटरी शुरू करेंगे हम लोग पढ़ना। और प्लीज
सर आज का जो पीडीएफ है ना, कंप्लीट है पीडीएफ नंबर थ्योरी का।
नंबर 3 का भी हम सीधे हम रोज इसको अपडेट करते हैं, कुछ मिलता है तो अपडेट कर लेते हैं।
सर आज जो नया ऐड किया है ना,
हाँ,
इसमें
भेज देंगे। और जो भी डिस्कस होता रहेगा, एक फाइल रहेगा, इसमें जोड़ते रहते हैं। जो भी
अच्छा,
पढ़ते हैं, पढ़ाते हैं, सब डिस्कस करते हैं, इसमें सब जोड़ते रहते हैं। वो सब
ठीक है।
ऑर्डर में हो तो सब इसमें जोड़ते रहते हैं। आपसे जो मिलेगा मटेरियल को क्रिएट करते रहते हैं।
ठीक है सर, थैंक यू सर।
हाँ ठीक है, तो हम अब भेज देंगे शाम तक। ओके
सर जी
ओके देन, प्लीज।
कह रहे सर कि जो 1000 फैक्टोरियल में जो था उसमें 0 निकालना था,
हाँ
तो सर उसको किए हैं।
हाँ, प्लीज प्लीज बताओ कितना आ रहा है आपका,
जैसे वो क्या सर
कितना आंसर आ रहा है?
आंसर आ रहा है हमारा 248।
ठीक है, ऐसा करो कि आप उसको कॉमन व्हाट्सएप ग्रुप में भेज दो, हम उसको क्रॉस चेक करते हैं और आपके दोस्त भी उसको क्रॉस चेक कर लेंगे। ठीक है, कोई डाउट होगा जैसे भी होगा हम लिखेंगे। ठीक है, ठीक है, ओके, थैंक यू, थैंक्स टू ऑल ऑफ यू।
थैंक यू सर। थैंक यू सर।